Hey guys, this is going to be a limiting reactant example video. So let me read out the question. So this question is asking how many grams of ethylene chloride, which is this species here, can be prepared by reaction of 15.4 grams of ethylene, so this species here, with 3.74 grams of Cl2. So here's the balance reaction written out. This would be given to you in the question since we don't know how to write organic compounds yet. So I'm going to show you how I would solve this problem. The very first thing I would do is just look at my balanced reaction, make sure everything's balanced, which it is, and then write down the given information that I have. So it's telling you how much of each reactant you have. So it says you have 15.4 grams of ethylene, which I'm going to write here, as well as 3.72 grams of Cl2, which I'm going to write here. And then finally, it's asking how many grams of product can you get. So I usually put a big question mark here. So how many grams of this? This is what we're trying to solve for. So like I said, whenever we're looking at these types of questions, we need to ask ourselves which one of these reactants is going to run out first. That's the first thing we need to do. So here, let me write it. Which reactant runs out first? So just like in lecture, we're going to take each one of these and figure out how many grams of product we could possibly get. And whichever one gives us less is going to be the thing that runs out first, or our limiting reactant. So let's start here. We have 15.4 grams of C2H4. We want to go from grams of C2H4 into moles. So grams of C2H4. This is something I do when I solve problems. I kind of just write down the general work, and then I'm going to go back and figure out what this quantity is later. So we're going from grams into moles. We now have to go from moles into moles. So how many moles of reactant for every mole of product? There's 1 mole of C2H4 for every 1 mole of product here. So the C2H4Cl2. And then finally, it's asking us for grams, so we need to put this quantity back into grams. So once again, for every 1 mole of C2H4Cl2, there's however many grams in this compound. And I'm going to figure that out later. So this is something that I'm going to go back and fill in these quantities once I have all of my work written out. So I'm going to do the same procedure here, but for this other reactant. So let's start with that. So we have 3.74 grams of Cl2. We need to know how many grams of Cl2 there are for every 1 mole to get into moles, Cl2. And then we're going to also use a conversion factor here between reactant and products. So every 1 mole of this gives 1 mole of this. This time it's trivial. Usually there's coefficients here, so you always have to do this step. C2H4Cl2. And then finally, once again, we're just going to go from moles into grams. So 1 mole of our product here is however many grams that ends up being. Once again, these are the 2 things I need to evaluate. Okay, so let's figure out these missing values here. So we need to come up with the molar masses of all of these things. Let's start with the Cl2 just because it's easier. So this is all, once again, from our periodic table. Say I don't have one here in front of me. I kind of solved for it ahead of time. So for Cl2, once again, the mass of chlorine from your periodic table will be this, 35.453. And there's 2 of them, and that works out to be 70.906. Let's do the ethylene next, so C2H4. So from your periodic table, this is the mass of carbon. There are 2 of them. And then this is the mass of the hydrogen, and there are 4 of them. So that ends up being, let me see, that ends up being 28.054, something like this. And then finally I'm going to do the product. So C2H4Cl2. You see, yeah, it just so happens that it's these two added together, but I'm going to put all the work here anyway. So here's for the carbon. There are 2 of them. Here's the mass of the hydrogen. There's 4 of them. And then there are two of these guys. So 35.453 is the mass of chlorine times 2. And all of that works out to be 98.960. Okay, so these are all grams per mole, of course. These are the molar masses. Grams per mole. So now that we have all of these things, we can finally fill in the missing pieces up here. So like I said, our product is 98.960. So you can fill both of those in, 98.960. And we need the molar masses for these two. So this is 70.906. And this is 28.054. Okay, so now we have all of the missing information. We're going to see how much product we can form from each one of these reactants. And yeah, so we can finally evaluate these. So I recommend typing this into your calculator just to get some practice to see how it'll go. I already did it ahead of time though. So this top one, I'm going to write it down here, is going to end up being 54.3 grams of our product. And then this one here is going to work out to be, where did I write that? 5.22 grams of product. So C2H4Cl2. So these are the amounts of products we can form from each one of these amounts of reactants. So the question here is, how many grams could we possibly form? And the answer is, of course, the lower amount. So the answer is 5.22 grams. We're going to use up all of this and have excess of this left over. But the point is that if we use up all of this, this is the maximum amount of product that we can make. I'm going to show you in the next video how to figure out how much excess reactant is left over.